Okay, I'll go ahead and get started. Good afternoon. My name is Aspen Hopkins, and I am going to be presenting joint work with my collaborators, Isabella Struckman, Kevin Kleiman, and of course, Susan Silbey. And today we'll be talking about AI supply chains, how stakeholders, markets, and the complexities of AI shape harm and inform redress. I want to start with a fairly direct provocation, which is that AI systems are increasingly the result of fragmented development across multiple organizations contributing models, data, and AI services. And these kinds of composed systems are embedded throughout our daily lives. Consider an example of a patient going to an ER, complaining of a stomachache. In the ER, they tell their provider some details. The doctor discusses the symptoms and makes some observations to direct next steps of their care. This conversation is transcribed and summarized by a voice-enabled AI assistant, which updates the electronic health record of the patient. This might sound familiar. These notes are fed into an upstream or downstream sepsis model, which flags high-risk patients for escalation to support triage. This information is then fed back into an EHR system with information about the patient's risks. This interdependent system I just described is an example of an emerging phenomena we call AI supply chains. We can redraw this system view to emphasize which components are doing what at any given time. Going back to our example, it turns out that the patient displayed symptoms of sepsis, but was not flagged in a timely manner. If I were to ask you which component in this AI supply chain is most likely responsible for this failure, you'll probably say the sepsis model. After all, this is the AI component that is actually monitoring for sepsis. And you would be sort of correct, but also incorrect. I'm here today because this problem is not as clear-cut as we might think initially. It turns out that a few days ago, in our example, the voice-to-text app had a system update. The update overall improved quality and accuracy of patient summarizations, but for a subset of doctors with specific accents, it actually experienced a regression, a distribution shift from its expected behavior. And this introduced unwanted distortions in the EHR record, like mistranslating keywords. Information about this update wasn't necessarily shared with the sepsis model developer, and in fact, that developer might not be aware of the voice-to-text app in the first place. The challenge is that the crisis that I just described isn't necessarily a technical failure on the part of just the sepsis model provider. This is an AI supply chain failure. Harms like poor patient outcomes, the sepsis model provider losing customers over ineffective products, loss of hospital reputation, are all the results. But who is actually responsible? And how can AI supply chain participants fix it? Can they even do this without the help of the upstream voice-to-text app? I'm here today because AI supply chains are human-made. That means that we can design them. But to do so, we must ask who participates in these systems, what happens when harms occur, and how do power differentials and market structures shape our ability to respond? Poignantly, there is no one-size-fits-all in AI supply chain configurations. This makes generalizing interventions exceptionally difficult. There are also many stakeholder roles. There are infrastructure, data, and model providers. There are user and consumer-facing developers. There are intermediary AI services. And of course, there are users and consumers. AI supply chains are not just technical. They're institutional arrangements with many stakeholders that have incentives shaped by contracts, limited coordination or accountability, and that often play multiple roles. What this means is that even those who cause harm, failing to capture the sepsis, for example, may be constrained in responding due to position or to market incentives. To restate this, stakeholders in AI supply chains operate with unequal bargaining power. Variations in power and influence shape outcomes, and this becomes most evident when we examine not the harm itself, but how a responsible party responds to a harm. In our work, we contribute a typology of redress. We ask, how do we respond to harms? Now that we've seen some examples of harms that can emerge in an AI supply chain, we need to think about how do we fix them. We describe 5 different cases of responses: recognition, in which you acknowledge that a harm occurred; recourse, in which you stop the harm; repair, in which the harm is corrected; reparation or compensation; and prevention, in which we learn from and then ensure that future harms are mitigated by adopting new policies or processes. These forms of response are common across domains, but they operate differently depending on who you are in the system. So when I ask, will redress happen? We have to note that it's not just about issuing a fix or a refund. It's more complex. It involves determining who can act, and what's technically and organizationally possible, and whether there is enough agreement among stakeholders to make something happen. In other words, we can define redress as possible when 2 things hold: that the redress is achievable physically, technically, legally, and that there's minimal consensus, meaning the relevant parties agree to act or can be compelled to. That's where things get tricky in AI supply chains. There's not systems where any one company owns and operates everything. They're fragmented, built from models, services, and infrastructure spread across firms with different incentives and levels of control. So when a harm occurs, say a patient is misprioritized, or a hospital loses trust in a system, the path to fixing it is often blocked not by malice, but by structure. The question then becomes, what shapes what is achievable? What makes consensus possible or impossible? In AI supply chains, the answer is market structure and institutional arrangements. The ways that AI services are sourced, built, delivered, whether they're vertically integrated, horizontally, modular, or fragmented into microservices, directly shapes what kinds of redress are even on the table. And often the same features that make AI scalable or cost-effective also make harm harder to trace and fix. In our work, we examine this across 3 common configurations. I'm going to focus on the vertical integration because of time constraints. So let's look a little bit more closely at how a harm and redress plays out in this setting. In a vertically integrated market, one firm owns the full stack. In our example, this might mean that the voice-to-text app, the sepsis model, and the EHR system is all owned by one company. Perhaps you can think of examples. In vertically integrated markets, that firm gets to decide whether the harm is even recognized. Recourse, the ability to avoid or disable a harmful component, is limited because you can't remove one piece without necessarily leaving the ecosystem. Repair is sometimes easier because the firm controls the whole stack, so you can choose what to fix and you can choose to holistically fix it. But fixes are prioritized based off of business interests and not stakeholder needs. When it comes to reparation or compensating people who are harmed, things get murkier. Without transparency, firms can minimize or obscure their role in the harm, making it difficult for affected parties to even ask for compensation, let alone receive it. And prevention, making changes to avoid future harms, is often only prioritized when there's external pressure, say from regulation, public outcry, or reputational risk. Across the board, market structure doesn't just determine who builds what, it constrains how and whether harm is addressed. So if these supply chain specific harms aren't caused by one actor or one broken model, but by the way the system is organized, then the fix itself can't just be technical. It has to be structural. And that brings us to our final point, which is intervention is possible, but it has to be targeted and it has to be intentional. When we say designing AI supply chains, we don't just mean choosing what APIs to use or how to fine-tune a model. We mean shaping the institutional context in which these systems operate through law, governance, and market mechanisms. This can look like regulation, which forces transparency, traceability, or auditability, licensing standards, procurement criteria, especially in public sector AI that demands evidence of recourse or repair mechanisms, contractual frameworks that clarify accountability between firms, and yes, tort law. Where harm can't be avoided, there must be pathways to compensation. The point here isn't that one solution can work everywhere. Harms are fundamental to risky business and to new technology. Each of these interventions can target a specific structural barrier to redress for all stakeholders, and together they can help build systems where it's possible to act before harms cascade. The final point I want to leave you with is that AI supply chains are not natural, they are made, and that means we can design them differently. We can design for transparency, for interoperability, for feedback channels that let stakeholders identify harm early and to do something about it. We have to look at the entire system, the actors, the markets, the institutions, and ask who has the power to respond when things go wrong, who's left without a voice, because in an AI today, those answers are often frankly structured long before the harm occurs. Thank you.
Awesome. Thank you, Aspen. Questions for Aspen? Sorry, I missed that one. Yeah.
Thanks. There is a significant body of work on digital supply chains. What's different? What does AI bring into the mix, which is different or substantially new?
Yeah, that's a wonderful question. I think this is a question on many people's minds. So we have a bunch of work that we actually didn't include in this presentation. Some of it talks about what's new to AI from the supply chain perspective. The other side is what's new to supply chains from the AI perspective. I think one of the challenges with AI specifically is that you are operating off of distributions. So you're learning and producing distributions rather than modular components that have inherent traceability, which you do have in digital supply chains, like software. Software is traceable. Granted, that was designed for, but in many cases, it is hard to take two different probabilities and understand where the probability, it's like the output that you get itself comes from. You have issues of like no one-to-one mapping, or you have things like collapsing distributions, and it becomes exceptionally challenging to do this traceability that we care about. Or it becomes computationally expensive, and therefore you have to have ownership over the model or whatever it is.
Great. Other questions? Yeah.
I should also say that Susan's in the audience and is very respected when it comes to regulation, so ask her questions as well.
Yeah, so the question that I have is regarding thinking about this supply chain that you outline. Like there's a different stakeholder along this supply chain, and how can you bring, we're talking about design, it seems to be that design in a relative isolated environment when you're talking about design, but then the impact is actually there's multiple stakeholder, multiple party involved, and how can you ensure that their incentive, their interests kind of align with this kind of design process? I'm particularly thinking about in this kind of environment of a hospital, healthcare related, that probably a strong interest from insurance standpoint. So, for example, hospital want to make sure that the kind of case that happened early introduced is very little, so that the insurance premium won't be increased next year, something like that. And that kind of incentive probably would help you kind of try to make optimize of design.
I see. To interpret your question, I feel like there are 2 or 3 parts. The first was that it's hard to design for systems that have very complex incentives that may not necessarily align, right? Susan has a body of work on regulation and on the commonplace of law, how when law is written, it is actually interpreted. Often there has to be an adjudication process. The point of our work is actually to highlight that these misalignments and incentives, and perhaps more critically, the relationships and powers across AI supply chains can push away some of the necessary pieces of the conversation. And so like, I think your comment around insurance being a narrative that we can align around, I'm not sure that I necessarily agree per se. I think that it can surface some of the challenges, and the question that I would have then is the people who are designing these mechanisms for ensuring more transparency and communication around updates, how they do so in a way that does not center only the insurance company, but also looks at these more modular components. I think Susan has an answer though.
Thank you.
It's on.
Hello? Oh, sorry. Thank you for that very fine question. And it is a very complicated question and situation, which you, by your question, illustrate that it is very rare to be able to create a system of traceability and accountability with so many stakeholders with divergent interests. And that is basically the history of government regulation. There is not a way for the market by itself to be able to do that. The market requires minimally a system of contracts and torts to enforce it, but that relies on the resources of the individual actors. In a complex supply chain, they're not going to be aligned. So the comments that Marise made at the end of her presentation just before on almost the same example of a problem in data in the hospital, she made the point that it is only through the collective resources and information collected by government agencies that one can see across the competing interests and compromise to some sort of set of boundaries and responsibilities. Though, as Aspen puts up, short of government, in the past, industries have self-regulated. This one has not.
There are some attempts to, particularly in the agentic space. There's something that the Silicon Bros are excited about called Model Context Protocol. It is an example where a system is being designed already with that comment that I had earlier, the structure is in place before the harm necessarily occurs. And so, you know, participatory design maybe is one solution to this.
Thank you. Any further questions?
There's also a lot of very interesting technical problems. If you're interested in those, please chat with me later.